you that the roads you may have traveled on in Europe were designed 2,000 years ago, not for cars, but for legionnaires' sandals. Thousands of kilometers of perfectly straight lines cutting through mountains, crossing swamps, and connecting London to the Middle East were built by hand, without a single bulldozer or laser level. These are not just roads, they are monuments to engineering that have outlived the empires that created them. Watch the video to the end to find out what secret ingredient the Romans added to their mortar, and why their bridges and roads are still standing today, while modern highways require repairs every 10 years. I will reveal to you the most closely guarded secret of the Roman Empire. Its greatness was based not only on the strength of its legions, but also on the speed with which those legions could move. The entire philosophy of Roman governance was built on controlling vast territories inhabited by dozens of different peoples. This control would have been impossible without rapid communication and the ability to instantly transfer troops from one hotspot to another, whether it was foggy Britain or sun-scorched Syria. At its peak, the Roman Empire stretched for millions of square kilometers, from the Atlantic Ocean to the Euphrates River. Managing such a colossus was an incredibly difficult task that required a constant flow of information and orders from the center. The old dirt roads, which turned into impassable mud after the first rain, were a bottleneck that stifled Rome's ambitions. The empire needed a system that worked like clockwork, in any weather and at any time of year. Military necessity was the main driver of this grandiose project. The legions were the foundation of Roman power, and their mobility was the key to the state's survival. If a rebellion broke out somewhere, the legion had to arrive on the scene and suppress it before it spread to neighboring provinces. Roads became an extension of barracks, allowing soldiers to march at full speed for tens of kilometers a day. That is why the famous phrase says, "All roads lead to Rome." But it also had the opposite meaning. All roads led from Rome, carrying its will, its soldiers, and its laws to the farthest corners of the known world. It was not just a transportation network, but the physical embodiment of imperial power, carved in stone on the face of the earth. Each new mile of road meant that civilization had advanced another mile. In addition to the military, there was also an acute economic need for reliable roads. Rome was a gigantic city that consumed enormous amounts of resources brought in from all over the empire. Grain from Egypt, wine from Gaul, metals from Spain. All of this had to be delivered quickly and safely. Roads became the arteries through which the economic lifeblood of the empire flowed, nourishing its capital. Communication was also important. Rome created the world's first state postal service, known as the cursus publicus. Couriers on light carts or on horseback raced along these roads, delivering the emperor's decrees and reports from governors. The speed of this communication was unprecedented in the ancient world and allowed for coordination over vast distances. The engineers who designed these roads were not just solving an immediate problem, they were laying the foundation for the future. They thought about durability, about their creation serving more than one generation. This philosophy of building for the ages permeated every stage of the work, from choosing the route to laying the last stone. They were not just building a road, they were building eternity. The most famous example, and perhaps the prototype of all imperial roads, was the Appian Way, whose construction began in 312 BC. It connected Rome with southern Italy and was so well built that it was nicknamed the Queen of Roads. Its straightness, strength, and thoughtfulness became the standard for all subsequent projects throughout the empire. As a result, the Romans created a network of more than 80,000 kilometers of powerful paved highways. This is not counting the hundreds of thousands of kilometers of secondary, dirt, and gravel roads. This web covered the entire empire, connecting the most diverse cultures and peoples under the rule of Rome. This entire system was a symbol of order that replaced chaos. Roman roads were straight, logical, and predictable in a world that had previously been full of uncertainty. They carried not only legions, but also the very idea of Roman law and Roman civilization. We would love to hear your opinion. Which aspect do you think was more important for Rome, military or economic? Write about it in the comments and don't forget to subscribe to our channel. Are you ready to learn the truth about how these roads were built? The success of Roman engineers would have been impossible without precise instruments and skilled professionals who knew how to use them. These people, known as mensores or surveyors, were true masters of their craft. They didn't just measure distances, they laid the foundation for the future paths that legions, merchants, and ambassadors would travel. Their work determined how quickly the army would reach its destination and how reliable communication between provinces would be. Surveyors were considered some of the most respected professionals because the very power of Rome depended on their accuracy. They were responsible for the first and most important stage, route planning. Their calculations determined whether the road would be straight, strong, and durable. The Romans believed that a road should not only be convenient, but also beautiful, as it reflected the face of civilization. Therefore, each section was carefully checked, and each turn had its own justification. Even the emperor, looking at the new road, could judge the skill of the engineers behind its creation by the straightness of its line. The surveyor's main tool was the groma. It was a simple but ingenious device consisting of a vertical pole with a horizontal crossbar at the top. Lead plumb bobs hung from strings at each of the four ends of the crossbar. The groma allowed perfectly straight lines to be drawn and precise right angles to be marked on the ground, which was critically important for Roman construction standards. The simplicity of this device is striking. Without any lenses, mirrors, or compasses, the Romans were able to achieve a level of accuracy that commands respect even from modern engineers. When a surveyor set up a thunder on the ground, he first chose a perfectly level spot. Often he had to level the site so that there were no distortions. Then, looking along two plumb lines in a straight line, he directed his assistants, who drove stakes into the ground. These assistants, usually young soldiers or slaves, had to follow the commands precisely without moving a step. After that, the surveyor turned the instrument 90 degrees and repeated the operation, creating a perfect grid for the future road. Thus, step by step, they marked out the future route of the road, which was striking in its straightness, often ignoring minor obstacles. Sometimes they had to lay a line through hills, bushes, and even old settlements. But straightness was considered a symbol of Roman order and power. For the Romans, a road was not just a path, it was a demonstration of their ability to subjugate the land, to make it obedient to the will of the empire. However, a straight line is good, but the road must also be level or have the correct slope. For this task, the Romans had another tool, the horabatus. It was a long, about 6-meter long wooden beam on two legs. A groove was carved into the upper part of the beam, which surveyors filled with water. The water served as a natural level. If it stood evenly, it meant that the surface was horizontal. The principle is simple but incredibly accurate. Even today, this method could give excellent results. By observing the water level, they could determine the horizontal with high accuracy. But sometimes the wind interfered. Then the horabat was supplemented with plumb lines on the sides. When the plumb lines coincided with special marks on the frame, it meant that the instrument was strictly horizontal. Such methods helped to determine the slope of the road so that rainwater would drain away without damaging the surface. Without this, the roads would quickly become unusable, and Rome would not have been able to keep its roads in perfect condition. The horabatus was cumbersome, but its accuracy was worth the effort. Surveyors carried it on carts and sometimes built temporary stands to raise the instrument above uneven terrain. Veterans of the service taught young craftsmen to determine the slope by eye, but they always checked the results with water anyway. It was the combination of experience and instruments that made the Roman engineering school unsurpassed in the ancient world. Measuring rods and chains of a certain length were used to measure distances. Every step, every elbow, every inch was counted with pedantic precision. Surveyors walked ahead, counting steps, recording distances, and recording everything on wooden tablets with wax styluses. But there was also a more complex instrument, similar to an odometer, which was described by the architect Vitruvius. It was a cart with a special gear mechanism that dropped a pebble into a bowl after traveling a certain distance, for example, 1 Roman mile. This cart was considered a marvel of engineering. Each pebble that fell into the bowl represented an exact distance. After completing the measurements, the surveyor counted the number of stones and obtained the length of the section. This made it possible to create maps and drawings with remarkable accuracy, thanks to which roads connected cities with minimal deviations. The mechanism worked so reliably that similar devices were used even in later centuries. In addition to these basic tools, engineers also had more complex instruments, such as the diopter. This was a device for measuring angles, similar to an early theodolite. It allowed for more complex triangulation calculations, which were especially important in mountainous terrain or when building aqueducts. With the diopter, it was possible to verify the direction with an accuracy of fractions of a degree, an incredible achievement for antiquity. Working with a diopter required experience. Surveyors mounted it on a tripod, aligned it with plumb lines, and aimed it at distant points. Sometimes they used mirrors to catch the sun's rays. Any mistake could result in the aqueduct not flowing or the road having too steep a slope. Therefore, only the most experienced specialists could work with this instrument. Route planning was an art. Engineers tried to lay the road on high ground to avoid flooding and ensure natural drainage. They studied the terrain, took into account the direction of the winds, and even the position of the sun, so that the road would not be destroyed by constant dampness or heat. They avoided swampy lowlands as much as possible. But if an obstacle, such as a mountain or a wide river, was unavoidable, other specialists came into play. And today, when archaeologists explore the remains of ancient roads, traces of their craftsmanship are still visible. Now that we have figured out the drawings, are you ready to learn the secret recipe for the roadbed itself, which has survived 2,000 years? I will reveal the most closely guarded secret of Roman builders. What allowed the roads to serve for millennia was hidden underground. A Roman road is not just a paved surface, it is a complex, multi-layered engineering system, more like the foundation of a modern building. Its design was thought out to the smallest detail, and the main enemy it fought against was water. It all started with digging a wide and deep trench called a fossa. Its depth could reach up to 1.5 meters. This stage was critically important, as it allowed the entire soft and unstable top layer of soil to be removed. The builders dug down to solid mainland soil or rock foundation that could serve as a reliable support. The first layer, known as statumen, was laid at the bottom of the trench. It consisted of large, often unprocessed stones, the size of a fist or even larger. This layer could be up to 30 or even 50 centimeters thick. Its purpose was to create a strong, unshakable foundation and provide primary drainage so that water would not accumulate at the base. On top of the statumen layer, a second thinner layer called rudis was poured. It consisted of small stones, rubble, or even broken bricks mixed with lime mortar or sand. This layer was denser, filling the voids between the large stones of the lower layer and serving to level the surface. The third layer was called nucleus, meaning core. This was the key element of the structure. It consisted of fine gravel, sand, and cement, which was often the famous pozzolana, volcanic ash. This layer was in essence a form of concrete, creating a strong and waterproof slab. Only on top of this concrete cake was the upper, visible layer laid, the summa crusta. Depending on the importance of the road and the materials available, these could be large, carefully fitted, polygonal stone slabs made of basalt or limestone. On less important roads, it could be simply compacted gravel. But the main ingenious discovery was not the multi-layered structure, but the drainage system. The road surface was always given a convex, humpback shape known as agar. Thanks to this, rainwater did not stagnate on the roadbed, but immediately flowed to the edges. This simple idea was the key to durability, preventing water from washing away the layers. Deep drainage ditches were dug on both sides of the road. This is where the water from the convex road surface drained. These ditches removed excess moisture from the road foundation, keeping it dry and strong. Roman engineers understood that water was the main enemy of any construction and did everything they could to neutralize it. The entire structure resembled a wall laid on its side. It was massive, durable, and practically eternal. The total thickness of all layers could exceed 1.5 meters. Such a road was not afraid of heavy rains, heavy carts, or even time. This technology was not only effective, it was universal. The Romans applied these basic principles throughout the empire, adapting them to local materials. Some places had more stone, Others had more gravel, but the multi-layered structure and focus on drainage remained the same. It was the gold standard of Roman engineering. It was this combination of deep foundations, multiple layers, and an ingenious drainage system that allowed these roads to survive for millennia. Many of them were used throughout the Middle Ages, and some still serve as the basis for modern European highways to this day. If you enjoyed this story about ancient technologies, please like and subscribe to our channel so you don't miss new videos about how people survived and built in ancient times. What if everything you've been taught about the legions is outdated? We are used to thinking of Roman legionaries exclusively as warriors marching into battle with shields and short swords. However, in peacetime, their main weapon was not the gladius, but the delabra, a versatile pickaxe axe. The Roman army was not only the most powerful military force, but also the largest and most organized engineering corps of antiquity. It was the legionaries who formed the backbone of the workforce in the construction of all strategically important facilities, including roads, bridges, and defensive ramparts. For a soldier of that time, the ability to dig a trench, cut stone, and build a bridge was as integral a part of training as sword fighting. The army was a self-sufficient unit capable of performing any task. Within each legion, there were entire units of specialists known as immunes. These were soldiers who were exempt from daily duties and hard labor because they possessed special skills. Among them were surveyors, architects, masons, carpenters, and blacksmiths who supervised the construction process. The work was organized with military precision. Each centuria, a unit of about 80 men, was assigned its own section of the road. The centurions were personally responsible for the quality and speed of the work on their assigned section. This created healthy competition and ensured a high pace of construction. Soldiers performed all the most difficult and skilled work. They were involved in surveying the terrain, laying out the route, building bridges and tunnels, and laying the final surface. This work was hard, but it maintained discipline in the troops in peacetime and made the legions even more resilient. Of course, the legionaries alone were not enough for such a huge amount of work. Therefore, the army actively recruited auxiliary troops, known as auxilia. Soldiers from these units, recruited from non-citizens of Rome, were used for less skilled but more labor-intensive tasks, such as digging trenches or carrying stones. In addition, the labor of the local population was widely used. In the conquered provinces, this was often forced labor. Residents of nearby villages were required to provide labor and materials for construction, and more importantly, for the subsequent repair of the road passing through their land. In some cases, especially when building large structures in peacetime, slaves could also be used. However, they were never the main workforce on such strategic construction sites. The army preferred to rely on disciplined and trained soldiers who worked not out of fear, but for pay and on orders. The scale was impressive. Working in unison, a detachment of legionnaires could lay hundreds of meters of completely finished road in a single day. They worked like a well-oiled machine where everyone knew their task. Some dug, others brought stones, others laid them, and still others prepared the mortar. This approach turned the army into an instrument of creation and Romanization. Passing through new lands, the legion left behind not only conquered tribes, but also roads, aqueducts, and cities. The soldiers were, in the truest sense of the word, builders of an empire. But what exactly did they use to bind their structures together? In the next chapter, we will talk about a material that was stronger than stone. One of the cornerstones of Roman engineering success, along with the organization of labor, was their unique building materials. The Romans did not invent concrete, but they perfected its formula to such an extent that it was thousands of years ahead of its time. This material, known as opus cementitium, was a true technological marvel that allowed them to build quickly, on a large scale, and with incredible strength. The basis of this concrete was a mixture of lime, crushed stone or rocks, and most importantly, a unique component, volcanic ash. This ash, which the Romans called pozzolana, after the town of Pozzuoli near Naples where it was mined, had amazing properties. It gave the mortar incredible strength and, more importantly, the ability to set underwater. Thanks to pozzolan, Roman concrete did not simply dry out, but underwent a complex chemical reaction. The components of the ash reacted with lime and water to form a crystalline structure that only became stronger over time. This material was much more durable than the simple lime mortar used by other peoples. This liquid stone was ideal for road construction. It was used in the nucleus layer, creating a monolithic solid slab under the finish coat. This slab evenly distributed the load from carts and legions, preventing the road from sinking or deforming. It also served as a powerful waterproofing barrier. But the full power of opus cementitium was revealed in the construction of bridges, viaducts, and port facilities, which were an integral part of the road network. The ability to harden underwater allowed the Romans to erect bridge supports directly in the beds of turbulent rivers. They built wooden caissons, pumped out some of the water, and poured their magical concrete inside. This material was malleable during work, but after hardening, it turned into a monolith that was as strong as solid stone. The Romans used it to pour foundations and create arches and vaults. This significantly accelerated and reduced the cost of construction compared to using only hewn stone, which required long and painstaking fitting. Another important material was, of course, stone itself. The Romans were masters of quarrying. They extracted millions of tons of basalt, granite, and limestone for their construction projects. The stone for the top layer of the road, summa crusta, was selected with particular care. It had to be hard, wear-resistant, and easy to work with. The logistics of delivering these materials was a separate engineering challenge. Stone and sand were often transported from quarries located dozens of kilometers away from the construction site. Heavy carts pulled by oxen were used for this purpose, traveling along sections of road that had already been built. Marble and porcelain were transported over long distances by sea and river. A whole arsenal of tools was used to process the stone: pickaxes, hammers, chisels, and wedges. The masons, many of whom were specialist soldiers, were able to shape the slabs with great precision. This was especially important for the top slabs, which were fitted so tightly together that it was difficult to insert a blade between them. The combination of these factors, rock-solid concrete, high-quality stone, and organized logistics, created the effect of durability that still amazes us today. The Romans did not simply pave the road, they created a monolithic structure, a single entity with the earth on which it lay. What I am about to show you is banned in 12 countries. Just kidding, but Roman engineers really did act as if there were no restrictions imposed by nature. The straight line was a cult for them. If a river, swamp, or even a mountain stood in the way of the ideal route traced by lightning, they did not look for a detour. They went straight ahead, demonstrating the complete domination of engineering thought over the landscape. Rivers were one of the most frequent and difficult obstacles. To overcome them, the Romans built bridges that were masterpieces in themselves. The basis of their design was a semicircular arch, an ingenious invention that allowed them to span large distances and withstand enormous weight. The arch distributed the load evenly, transferring it to massive supports, or bulls. The construction of the bridge supports was the most difficult task. As we have already mentioned, the Romans used their waterproof concrete. They built cofferdams in the river, temporary waterproof barriers made of double wooden walls, the space between which was filled with clay. After pumping out the water, they poured concrete and stone foundations directly onto the riverbed. One of the greatest examples of this type of bridge construction is the Alcantara Bridge in Spain, built at the beginning of the 2nd century. It spans the Tagus River and has 6 arches rising to a height of almost 50 meters above the water. The bridge bears the inscription, "The bridge that will stand forever," and it has indeed stood for almost 2,000 years. If a mountain stood in the way, engineers had 2 solutions. The first was to cut a notch in the slope, creating a shelf road. But if the mountain was too big or a straight route was required, they would dig a tunnel. This was incredibly laborious work, carried out with pickaxes and chisels, and to speed up the process, the rock was heated with fire and then rapidly cooled with water, causing it to crack. A striking example is the Furlow Tunnel on the Flaminian Way in Italy. It is a gallery almost 40 meters long, cut through solid rock. For the ancient world, which did not know explosives, this was a colossal achievement that required months of hard work. The Romans did this to keep the route straight and convenient. No less difficult a task was the marshy terrain. The Romans hated swamps, as the unstable ground was a curse for their heavy roads. Here they used the technology of causeways. Thousands of wooden piles were driven into the swamp to create a stable foundation. Logs were laid on top of the piles and a multi-layered pie of road was laid on this platform. In other cases, viaducts, long bridges consisting of multiple arches, were built across lowlands and gorges. They allowed the road to remain at the same level without forcing carts and legions to descend and climb steep slopes. This saved time and energy, which was critical for the rapid deployment of troops. To manage slopes in hilly terrain, engineers cut deep cuts into hilltops and built high embankments in lowlands. All the soil removed from the cuts went straight into the embankments, making the process as efficient as possible. They literally reshaped the landscape to suit their needs. All these structures, bridges, tunnels, viaducts, were not separate wonders, but standard elements of the road network. For Roman engineers, the word impossible did not exist. Any obstacle was just another task requiring a standard, well-calculated solution. But how was this gigantic network managed? We will discuss this in the next chapter. Roman roads were not just strips of stone, they were a living, pulsating system. To make this system work effectively, a complex infrastructure, a veritable logistics network, was created along it. Its most important element was the state postal and transport service known as the cursus publicus. It was, in essence, the internet of the ancient world, allowing information and officials to move at unprecedented speeds. This service was established by Emperor Augustus and was intended exclusively for state needs. Private merchants or ordinary travelers could not use it unless they had a special permit or diploma. It provided communication between Rome and the governors in the most remote provinces. The entire road network was divided into sections. At a distance of about 1 Roman mile, about 1.5 kilometers from each other, there were miliarium, or milestone stones. These were tall stone pillars on which the distance to the nearest large city was carved, and often the name of the emperor under whom the road was built or repaired. They were not just signposts, but symbols of the imperial presence. At longer distances, approximately every 10-15 kilometers, there were mutationes. These were small stations where the courier could change tired horses for fresh ones. Each such station had a supply of several dozen horses. This allowed the courier to maintain a high pace without stopping for long rest periods for the animals. Larger complexes called mansiones were intended for overnight stays. They were located at a distance of 1 day's journey from each other, which was approximately 30-40 kilometers. A mansio was not just an inn, but a full-fledged state institution. It had not only rooms for officials to rest, but also stables, food warehouses, and even small baths. Thanks to this system, urgent messages could cover huge distances. By changing horses at each mutatio station and riding day and night, a courier could cover up to 200 kilometers per day. This meant that news of an invasion on the Danube could reach Rome in less than a week, allowing the emperor to respond quickly. For less urgent but heavier loads, engriae were used, slow carts pulled by oxen or mules. They transported state cargoes such as food for the army, building materials, or taxes collected in the provinces. They also had their own system of warehouses and rest stops. Maintaining this gigantic network was an expensive undertaking and placed a heavy burden on the inhabitants of the provinces. They were obliged to provide provisions, fodder, and horses for the needs of the cursus publicus. However, the effectiveness of this system justified the costs as it held the empire together. The Romans even created special roadmaps, or itineraria. The most famous example is the Peutingera table, a medieval copy of a Roman map in the form of a long scroll. It shows a schematic representation of the entire network of imperial roads, indicating cities, mansion stations, and the distances between them. This meticulously planned infrastructure transformed roads from passive structures into an active management tool. It provided what was vital for any empire: control and communication. Roads were the circulatory system, and the cursus publicus was the nervous system, transmitting impulses from the brain in Rome. Building a road is only half the battle. The Romans, being excellent administrators, understood perfectly well that even the most durable structure requires regular maintenance. Without constant maintenance and repair, any road would quickly fall into disrepair, under the influence of weather and heavy traffic. Therefore, Rome created an entire system to monitor the condition of the road network. Special high-ranking officials, curatores viarum, road curators, were responsible for the main roads leading out of Rome. It was an honorable position to which senators or people from the emperor's entourage were appointed. They managed the funds allocated for repairs and monitored the general condition of the highways entrusted to them. Financing repairs was a complex issue. Part of the funding came from the imperial treasury, especially when it came to strategically important military roads. However, a significant portion of the costs was shifted to local landowners whose estates were adjacent to the road. They were required to maintain their section in proper order. The cities through which the road passed were also responsible for its condition within their boundaries. They collected local taxes and duties, which were used to repair the pavement and clean the drainage ditches. This decentralized system allowed minor damage to be repaired quickly. The main task in maintenance was to keep the drainage system in working order. The ditches on either side of the road had to be regularly cleaned of silt, leaves, and debris so that water could flow freely. If the drainage became clogged, water began to accumulate at the foundation, which inevitably led to its erosion and subsidence of the roadbed. It was also necessary to monitor the condition of the pavement itself. Summa crusta stone slabs could crack or be knocked out of place by heavy carts. Repair crews, often consisting of the same soldiers or local residents, had to replace damaged slabs in a timely manner and level the pavement. On gravel roads, which made up most of the secondary network, maintenance was even more regular. The gravel surface had to be periodically renewed by adding fresh material and constantly leveled to prevent ruts and potholes from forming. In addition to technical maintenance, the Romans also took care of road safety. Small garrisons were stationed along the highways to protect travelers from bandits. This made travel throughout the empire relatively safe, which contributed to the flourishing of trade and cultural exchange. The center of the entire road network was the Miliarium Aureum, or Golden Milestone. This column, covered with gilded bronze, was erected by Emperor Augustus in the Roman Forum. It listed the largest cities of the empire and the distances to them. It was a symbolic 0 kilometer from which all roads were measured. This comprehensive system of administration, financing, and regular maintenance was as important as the construction technology itself. It ensured that the roads would serve not for decades, but for centuries, fulfilling their main function, connecting the empire into a single whole. Although the roads were originally built for military and administrative purposes, their impact on the economy and culture of the empire was no less, and perhaps even more, significant. Roads became a catalyst for the globalization of the ancient world. They connected distant markets and allowed goods, people, and ideas to move at speeds that had previously been unimaginable. Before the Romans, long-distance trade was mainly maritime. Land transport was slow, expensive, and very dangerous due to bandits and poor roads. The Roman Viae network radically changed this situation. For the first time, it became profitable to transport bulk goods such as wine, olive oil, ceramics, and textiles deep into the continent. Merchants could travel safely under the protection of Roman law and garrisons. They knew exactly how long the journey would take and where they could stop for the night at mansiones. This led to the rapid growth of cities located along key highways. They became bustling commercial centers and craft hubs. Not only goods were transported along the roads, but also raw materials. Metals from Spain, marble from Greece, wood from Gaul. All of this was delivered to craft centers and large cities. This fueled Roman industry and made it possible to implement large-scale construction projects throughout the empire. Ideas traveled alongside merchants. New philosophical teachings, religious cults, and artistic styles spread rapidly from one end of the empire to the other. Roman roads became the main instrument of Romanization, the process by which conquered peoples adopted the Latin language, Roman laws, and way of life. Soldiers who had served their time in the legion often settled in the provinces where they had served, founding colonies of veterans. These settlements, built on the Roman model and connected to the rest of the empire by good roads, became centers of Roman culture. They demonstrated the advantages of civilized life to the local population. Tourism, at least in the ancient sense of the word, also became possible thanks to the roads. Wealthy Romans could afford to travel to Greece to see the birthplace of philosophy, or to Egypt to marvel at the ancient pyramids. They traveled in comfort, using the same infrastructure as government officials. Roads also contributed to the mobility of the population. Craftsmen, doctors, teachers, and artists moved from city to city in search of work. This created a unified cultural and economic space in which a person from Gaul could pursue a career in Rome, and a Syrian merchant could settle in London. Of course, there was a downside to this mobility. The same roads that brought prosperity could also quickly spread rumors and discontent. Infections also traveled at the same speed as couriers. However, the positive effect of uniting the world was incomparably greater. Thus, roads were not just engineering structures, they were a social and economic mechanism that forged dozens of peoples into a single Roman civilization. They created a world in which, at least for several centuries, order and prosperity reigned. Why have these roads built 2,000 years ago survived to this day in many places? The answer lies in three key factors that Roman engineers elevated to an absolute: ingenious design, high-quality materials, and, oddly enough, constant use. Together, these elements created a monument that proved to be more durable than the empire itself. The first and most important secret is the fight against water. As we have already discussed in detail, the entire road design was subordinated to one goal: to divert water away from the foundation. The convex profile of the agger and deep-side ditches prevented moisture from accumulating on the surface and penetrating deep into the ground, washing away the foundation. Most ancient roads collapsed precisely because their builders ignored this problem. The second factor is over-engineering, or construction with excessive strength reserves. The Romans did not skimp on the foundation. A meter or even a meter and a half thick layer cake of stone, rubble, and concrete was designed for loads that simply did not exist in the ancient world. It was excessive even for heavy military carts. This excessive strength allowed the roads to survive centuries of neglect. When the Roman Empire fell, the centralized road maintenance system collapsed. In the Middle Ages, no one cleaned the drainage ditches or replaced cracked slabs. The roads fell into disrepair, but their foundation was so strong that it withstood centuries of neglect. The third factor is materials. The use of waterproof concrete based on pozzolan and hard rock, such as basalt for the top layer, made the construction almost eternal. This concrete did not deteriorate over time, but only gained strength. The stone slabs were resistant to abrasion and weather conditions. Finally, many Roman roads have survived because they never stopped being used. Their routes were so logical and straightforward that subsequent generations continued to walk and drive on them. Throughout the Middle Ages, they remained the main transport arteries of Europe. When road construction began to revive in modern times, engineers often saw no point in laying a new route. They simply built new roads on top of the old Roman ones, using their unmatched foundations as a base. Many modern highways in Italy, France, Spain, and Britain exactly follow the route of the ancient Vie. The most famous example is the Appian Way. Significant sections of it have been preserved in their original form, and today you can walk on the same stone slabs that Caesar's legions and the first Christians walked on. It is a veritable open-air museum, a living testimony to Roman genius. Roman roads are not just ruins. They are an active part of our landscape. They determine the settlement pattern and transport flows of modern Europe. The cities they connected are still major centers today. The legacy of Roman engineers is not stone, but the very structure of our civilization. They did not build for decades, they built for millennia. Their planning horizon extended far beyond human life. Every stone laid, every bucket of concrete mixed, embodied the idea of eternity, the idea of Roma Eterna, eternal Rome. And although the empire itself has long since disappeared, its roads remain, a silent reminder of what the human mind is capable of when armed with discipline, organization, and a great purpose. They prove that true greatness is measured not in conquest, but in what you leave behind. We can see that Roman roads were not just transport routes, but a complex system that included advanced engineering solutions, strict organization of labor, well-thought-out logistics, and constant maintenance. It was a technological marvel that became the foundation of the military, economic, and cultural power of the Roman Empire. Their legacy is not just stones under our feet, but the foundation on which the entire Western civilization grew. We have examined construction technologies in detail, but the history of ancient Rome is full of other amazing engineering achievements. What would you like to see in the next videos? Perhaps you are interested in how the Romans built giant aqueducts that supplied water to cities, or how their siege engines worked. Suggest your topics in the comments. Your opinion is very important to us, and it helps us decide which secrets of the past we will reveal next time. And of course, don't forget to subscribe to our channel so you don't miss out on new exciting research.